Okay, good morning, everyone. How did the rest of the homework go? Do you have any questions about the worksheet? Please put them on chat or mute and tell me your questions before we start. Can you do 5B? Sure. Okay, so we'll do number 5B. Here. What we have, find the domain of each of the following function. So we have, so that's the domain, because it's always, domain is important. We have to know always what values of x we are allowed to put for the input. So here, this is my function, it's a natural log. That's the inside, so now x squared minus 1. And the log is defined whenever the input is positive. So we need to solve x squared minus 1, a positive number. X squared minus 1 positive, it means x squared has to be larger than 1. If x squared is larger than 1, when can this occur? When the square root of x squared is larger than 1. And now the square root of x squared, which is the confusing part, okay, it means that the absolute value of x has to be bigger than 1. So now I'm looking for all the x's. When you put them in absolute value, you get bigger than 1. So what are all the x's? So everything bigger than 1 will satisfy. But not only that. If I take minus 2, when I take the absolute value of minus 2, I get a number bigger than 1. If I take minus 1.5, absolute value bigger than 1. Minus 1.2. So also every value of x, which is less than 1, will make the absolute value bigger than 1. So the domain is going to be all values of x such that x has to be bigger than 1 or less than 1. And in interval notation, so basically I'm looking for all the x's, so this is my interval. This is minus 1, this is 1, this is 0. I'm talking about x could take any value in here and any value in here. So it means basically when we draw the graph of this function, we're going to have two pieces. So I don't know exactly how, so you're going to have one piece here and we're going to have another piece here. So there will be nothing, no output when x between minus 1 and 1. So in interval notation, I write everything from minus infinity to minus 1, everything less than 1, everything bigger than 1. And the way we connect or mathematically the symbol is this U. And thus it means both of them. Okay. Questions before we proceed? All right, now we look at number 6B. Okay. Here the question is, sketch the graph of each of the function, and definitely I don't want you to use the calculator. I want you to use shifting and reflecting. So we have the following function, ln minus the ln of x minus 1. Okay, so the question is, if we start from ln, so start from ln of x, that's my starting function. How can I get ln of x minus 1? Okay, yeah, go ahead, guys. What shall I do first? What shall I do second? And then we sketch the graph. So ln of x, how do I get ln of x minus 1? We're gonna, yeah, you're right. So we're gonna shift to the right. by 1. This will give me the function ln of x minus 1. And then we reflect across the x-axis, and this would give me the minus ln of x minus 1. So this is the process. Very good. Now another question also, what's the domain? And we will see it when we graph also, but always the domain. The domain very quickly. What's the domain? What do we need? What's inside, the only values of x that are allowed inside are the positive x's. So when we graph, we will have output only when x is bigger than 1. Now we do the graphing. Okay. We start with ln, that I told you is crucial to know its graph. ln of 1, it's 0. When x takes small negative values between 0 and 1, when x becomes very close to 0, the graph goes to minus infinity, and that's my ln of x. That's my original graph. Now I need to shift it by 1. So what happened at 1? Now at 2, the function will take the value 0. The initial one took 0, ln of x takes the value 0 at 1. ln of x minus 1 will take the value 0 at 2. Actually, if we plug in 2 here, I will have 2 minus 1. It means ln of 1. So it takes 0. Now, the original function ln of x, when x becomes close to 0, the function goes to minus infinity. When I shift, everything will happen now. Instead of happening between 0 and 1, it's being shifted, happen between 1 and 2. So now my function would look like that. So it's very close to 0, and it's be totally shifted. So this is the ln of the x minus 1. Okay. Finally, we reflect. And the reflection, usually it's not hard. So we reflect. So this is going to be reflected here. That's the reflection. And from here to here, we're going to reflect. That's the reflection. And this is my final function, not minus the ln of x minus 1. Of course, as you see, the domain is x bigger than 1. That's my domain. There is output only when x bigger than 1. All right? Very good. So today, as I said, we will have a crash course in trigonometry, because you guys spend months studying trigonometry, and I have barely an hour to do that. So I will start, as I said, it's going to be a crash course. I will not do every details of it. I do what I think I need for 163. And if anytime we need something, we just remind you of it. So trigonometric function, which is, I think that's the section, I think it's 1.4. Trigonometric function. All right. So first, let us a little bit remember the angle measurement, because it's important. So what are the two units that we use to measure angle? Put it on chat. Angle measurement. Okay, we measure angle degrees and radian. Absolutely. So degrees and radian. Okay, now degrees is basically a very arbitrary measurement. What do I mean by arbitrary? What is a degree? It's we take a point and we split around it, this piece, by like 360 pieces, as simple as that. So we split into 660 pieces equal. And the degree is one of them, 1 degree. What is the 360? It's an arbitrary number. It's a number that the Babylonian decided that's how many places they want to split this piece right there. So it's a very arbitrary, it's like an inch. It doesn't have any meaning. Inch is just an inch. Somebody decided from here to here is going to be the inch and everybody went along with it. A foot also is a very arbitrary unit of measurement. It was the size of the foot of a king of England. They decided that's going to be a foot. So this is a very arbitrarily measured, but we are very used to it by now. But that's how it is. It's from here to here. We divide this into 306 pieces and we pick up the piece. Radian is different. Radian is not an arbitrary measure. What is the radian? How is it? The radian is the following. Okay, we take the units, that's 0. So what is 1 radian? We take the unit circle. Unit circle means the circle of radius 1. So unit circle. Okay, it means circle of radius 1. And on this circle, so from here to here, we have 1. And then we cut from this circle an arc. So we take an arc. So start here and we take an arc so that this arc, its length, if you take this arc and stretch it, the length of the arc, the length is 1, the same as the radius. Okay, so we start with the circle of unit 1 and we take an arc of length 1. And then we take the angle at the center. So it's a very, very precise one. That's what we call 1 radian. So that's what's a 1 radian. That's really the definition of a radian. So unit circle, an arc of length 1, cut it off from the circle, the angle at the center, this is 1 radian. So it's a very geometric definition. It's not an arbitrary unit of measurement, even though that's the one we used to, but that's an arbitrary. This is not, this is absolutely a geometric one. So that's really what the radian. So now the question is, okay, my question is the following. So 2 radian means what? 2 radian means the following. You take 1 and then you take another one, length. So this is 1. So this will be 2 radian. That's really what it is. And so on, 3 radian, you need another piece and you get 3 radian. So the question is, how many radian can I put inside? Let's see, how many radian can I put from here to here? How many radian can I put from here to here? And what we know is, what's the length? So from, this is 1 radian, this is 1 radian. So from here to here, I have 2 units. But what's the maximum number of units that can go up to here? What's the maximum number of units? From this point to here, what's the maximum number of units? 3 radian, almost a little bit more, a little bit more, a little bit more, because we know that the circumference, it means the length of a circle, the length of the circle is 2 pi times the radius. Now I'm looking at a half a circle. So half a circle is pi. Pi means 3.14. So the length from here to here, this length is not quite, a little bit more. It's like 3.14. This is pi. So the angle at the center, which is exactly the length of this piece, is pi radian. Pi radian. So pi radian is nothing more, this angle here is nothing more than the length of this arc. So if I go, I have too many colors now. If I go around like this, how many radian I have? It's the length of, exact, that's the definition, the length of the circle, which is 2 pi. Okay, so pi is a very, very specific really unit of measurement. All right, so let us see what we're doing here. So what is pi radian? Pi radian, it means almost 3.40. That's what we have. So because of this geometric interpretation, we will be using radian all the time. So we will not be using degrees for angles at all. In calculus, degrees don't work. We will go to degrees only to have a better intuition, but we will use radian because that's really the geometric measurement. That's really the one we will work with, okay? Now let us remember the conversion between unit conversion between degrees and radian. The conversion is simple. As we said, if we go from here to here, this is pi radian. So pi radian, that's the only one you should remember, coincide to from here to here, because we split the whole circle into 300 pieces, that's 180 degrees. So that's the main conversion between them. So how much is a radian? So a radian, which is actually almost, it's important to memorize what a radian is, so we can have a picture in our head. A radian is 180 over pi. So a radian is almost, if we pick up our calculator and we do that, almost, I think, 57 degrees. And this really tells us exactly what's a radian. So a radian is huge compared to degrees. Degrees are very, very tiny, but the radian is not, it's almost 57 degrees. All right, so this is the conversion. And as I said, that's the unit that we will be using all the time. Now, very quick reminder of the most basic angle, so special angle, I'll call them. So in degrees and in radian. So the special angle, I mean the 0, the pi over 6, sorry. That's not what I want. Sorry. The 30, the 45, the 60, the 90, the 180, what else? 360, and this is, I don't know. We'll figure it out in a second. All right, let's do the conversions. 0 degree is 0 radian. And 180 is the pi. Once you know this, the rest is fairly simple. 90, half of 80 is pi over 2. 360 is 2 pi. And 45, or whatever, 30 is 1/6 of 180. 1/6 of 180, pi over 6. 45 is half of 90. 90 is pi over 2, that's pi over 4. 60 is 1/3 of 80. 80 is pi, the 1/3 of it is pi over 3. And then the other angle that we should know is the 3 pi over 2. The 3 pi over 2, which is the one in between 270 degrees. Absolutely, absolutely, we should know this angle, special angles, absolutely. All right. Now I will introduce a little bit sine and cosine, and then we take the quiz. So let us, sine and cosine. The first time you get introduced to the sine and cosine, you usually get introduced to the right angle definition of sine and cosine. Okay, the right angle, sorry. The right angle is not the definition we will use, but we have to make sure that the definition we will use is not is extension of this one, not something different. The right angle definition is the following. If you have a right triangle, I will call this angle theta, for example, and the sine of theta is, the cosine of theta is, and the tangent of theta is. So let us remember very quickly, the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over adjacent. And there are also secant and cosecant. I'll talk about that later. That's the right angle definition. Sometimes this is called the carpenter's definition, because that's what the carpenter used for sine and cosine. Okay. Now, what the definition we will use, and that's what the one we use, is what's called the unit circle definition. And let's see here. In the right angle definition, if I tell you what is the sine of, I don't know, let us say 100. You don't know what's the sine of 100 degrees, because in the right angle definition, we can only find the sine of angles less than 90. So whenever the angle is bigger than 90, this definition does not really extend anymore. That's why it's called the right angle. The idea of unit circle definition is to give me the sign, or to give a definition of the sign of any angle under the sun. Okay, so this one is very restricted to angles between 0 and pi over 2. But now we're going to define the unit circle for all angles. So I'll start very quickly for 2 minutes, and then next time we proceed. And the idea here is the following. We start with the unit circle. That's where those. It means we start with a circle of radius 1. That's my circle, radius 1. And I take an angle T. Now, how we gonna take it? We take the following angle. T is the angle form, so we take T is the angle between the positive x-axis, so let's say point P, and that's T. So T is starting from the positive x-axis all the way to this point. Okay, so we're gonna call P. P is a point on the unit circle. Let P be a point on the unit circle, and T the angle between positive x-axis and OP. That's the T. And as you know, that T can take any value. T can be more than pi over 2, more than pi. I mean, it can be anything. How do we define the sine and the cosine? And that's the important one, that the cosine, that's the definition. That's everything is based on this definition. The cosine is the x-coordinate of the point P, x-coordinate of P. So picture immediately. This is P. What's the cosine of this angle? It's the x-coordinate. That's the cosine. The sine is the y-coordinate. Okay. So the sine is the y-coordinate of the point P. Absolutely to be understood. I mean, not understood, to know. That's the definition of the sine and cosine. That's the definition of the sine and cosine. That's the one we will be using most of the time. All right, so I definitely would like to stop at this note to give everybody enough time to take the quiz. So I will put a worksheet on Brightspace, because most of you are familiar with this stuff. So it's not really something new, and try to work on it. And on Tuesday, I will finish the lecture and I'll answer your question about it. Okay, so we're gonna start taking the quiz. I'm giving you, I hope, enough time to do it. So let me remind you how we do that. So share this. And one thing, please, for some of you, I put a note that I would like the homework to be submitted as a PDF document. And if you don't know how to do it, I need a JPEG. The one I'm having trouble with is the one that you're giving me from, I think it's an iPhone, because it's HEIC. This is the one I have trouble downloading. So try to send a JPEG or PDF document. Okay, so let's share the screen and remind you how to do that. So you go to Brightspace, of course. I will go to the page that I think that's the one you see, and you go to content and you go to quiz, and it's quiz 2. Oh, I think I need 1 more minute. I didn't know that. Okay. Sorry, I planned it at 8:25, so in 1 minute. But basically, that's the quiz. Quiz 2, remember. And okay, I put due at 9 a.m. I'm going to extend it to 9:30. The reason is, so in case you have any problem with technology, you will have plenty of time to actually fix it. So it will open in 1 minute. Okay, I think.
I have class starting. Like I have to leave for.
You should be done. I just give you what?
I have to leave for the school, and it takes like half an hour for me to get there.
So at what time do you have to leave? Class ends at 8:50. Why don't you contact me later? If you really have problem, I will take care of that.
All right,
All
thanks.
right? So, are you with me?
Yeah.
Yeah. Try to take it. If you're really stuck, let me know, and we will take care of that. Is it making sense?
Yeah, I got you.
Yeah. All right. So, did it open or not yet? That's weird. It should open by now.
It's open. It's open.
Why it's not opening in mine?
The page.
You have to refresh the page.
Yeah. Okay. All right. Okay, it's open, and I put 9:30. So if you have any issue with connect, it shouldn't take that long. I mean, those courses are not take that long. But I don't know what's the connection that you guys have. So you just open it and get going. And if anybody has issue with timing, please let me know. Then you open here and you get going.
For part one, is the explanation just us showing work?
Yes, yes.